Okay, so here we are in the lab once again, and this is episode 3 of Build Your Own Main Brain Microcontroller project. And this is even a bigger episode because this is where we start learning about the microcontroller. And I know everybody wants to see the microcontroller. Oh, the microcontroller, the microcontroller. All right, well, we're starting it. And so in this video, we're going to be primarily concerned with, we're going to go over the website. And because the website is where all the files are stored that you need for the bill of materials, for the Fusion project, and for the Gerber files. So all that's on the website. So that's the support, antimatter.me. Easy to remember. So that is the support website. And so then we're going to get involved in the minimum requirements for to start up the microcontroller, to get code into it and to get connected to it, and what to use, what the programmer, because you got to have a programmer. But we're going to go through all that in this video. So check it out. And so also, I have a support website for MainBrain for the whole project. And it's pretty much just going to become Larry's Electronics Lab's website support page. So that's at www.antimatter.me, and everything that you need to know about MainBrain and these videos, as far as like supplementary stuff, is on that website. So check that out, browse through it, and I'm adding stuff to it right now, like I'm doing the firmware and the breakdown of the Windows application code, and eventually that'll be all spread out through the website in a big long flow chart mixed with code kind of thing. So let's jump over there at the website and see what it's all about. So the support page for MainBrain is at antimatter.me. That's a fairly easy one to remember. And incidentally, I actually owned antimatter.com originally, but I let it expire back in the 90s, and now this company has it and they want to sell it for like $100 grand or something like that. It's crazy. So I missed that one. Okay, so it just tells a little bit about MainBrain here on the first page. And then over here, there's a menu. So you got some USB code. This is the code that makes you able to connect with the USB. And it's a bare minimum. And I can chop it down. It's going to get chopped down a little more. I'm going to take some unnecessary things out of it later. But this is the basics of it right here. This is the C code. All right. And then we have reference, we have photo gallery, some utilities. Then we just have like, I have this for the retro PC video series. So there's a web page for that if you have an old computer that can't do the modern security features and stuff of HTML. And you can go here and test it. Then I have my top 50 music if you want to check that out, and then a contact. So with a reference is the main thing we want to talk about today. And so it takes you to another page with a list. So this is the bill of materials here for the latest revision, which is 1.2.541. And that should be the final revision unless I find something wrong in the next few days. And then the only thing that isn't available, let's see, here, if you go here, it takes you to a DigiKey list. And that DigiKey provides this for free. And it comes in pretty handy because it lists all your parts, and then you can order it right from DigiKey. Just click away, add it to the shopping cart. And this is the total cost of the items. I believe there's 43 items. Let's see. Yeah, 43 items, and then a data sheet for each item gives a circuit reference here. And then the description, of course, all that stuff. And so this is a good resource. So the inductor, I haven't got the inductor exactly set which one I want. So right now, the best one that works with the lowest noise is just a generic one you can get at Amazon. And I just buy one of these kits. And you can buy individually, I would think. But this is the company, whoever that is. And it's a 4.7 microhenry inductor. All right. And then the display. The display isn't available on DigiKey. So this is where I get it at Crystal Fonts. And they have a lot of displays, all kinds of displays. But this is the one that we use. And then they have some data sheets here, different specs, data sheets. And that just gives you, oh, you can download it. It just gives you the basic stuff here. But it is, the key thing is it uses this microcontroller inside. So you want to, if you want to program the screen on your own, then you're going to have to get the data sheet here on the controller. And the older one had a different controller. So this is a little bit newer, works a little bit better, but it's limited on information. It's really hard to get all the information needed to program it. All right, so then right here is our Fusion files for the Fusion project. It'll take you to let you download it right here. All right. And then you got the Gerber files. If you just want to cut a PCB, you can send these files to your shop. And the shop of your choice and have the PCB made. And then this is under construction. We are going to get some information about the Windows interface for MainBrain. And then we're going to go through how the firmware works. It's not done yet either. I'm just getting started on that, but there's going to be a flow diagram with code and everything, how it works. We'll go through that too in a later video. So that is the support site for MainBrain. All right, so the next thing to do is we want to look at the data sheet for the PIC32. So we just want to look at what the minimum requirements are to get the processor to start up. Because you don't want to have to build some big, long, complicated, sophisticated circuit just to get the processor going. And Microchip did a good job on it. You don't have to do very much to get it plugged into the programmer and get some code into it and start testing your code and building circuits. It's pretty easy. I mean, it could be a lot harder, that's for sure. And so let's take a look at the data sheet and we'll discuss it further after that. So here's our data sheet for the microcontroller. It is the PIC32MZ family. It has up to 2 megabytes of flash, and the one I use is the full 2 megabytes, but you can go cheaper and reduce costs by going smaller and a little bit slower. So it says the core can run up to 252 megahertz, and you can overclock it some. For us, the only other thing, it does have audio and graphics interfaces, but we use the PMP anyway. So that's just kind of the normal thing. We have high-speed USB. It has security features with the crypto engine, but only the 144 pin package has that, and I use the 100 pin package, so I guess I don't get the crypto engine. There's direct memory access channels, advanced analog features. So we use the 12-bit ADC. We use that to measure the board current and voltage. And it has a built-in temperature sensor for the CPU, so you can display that if you want. I haven't done that yet, but I intend to. Communication interfaces, I2C, I think that's what we use for the capacitive touch. We'll get into that later. All right, some timers, always use timers. I use all the timers pretty much for different things. We'll get into that. Input, output, some inputs and outputs are 5-volt tolerant. A lot of them, actually. Comes in handy. In our case, we don't really need to worry about that in main brain. And then debugger, it has JTAG, in-circuit, debugging, all kinds of stuff. And we'll use the in-circuit programming. We'll have to cover that. That's one of the major things. And then they have software support. They have a lot of tools and stuff. So, of course, C and C++. And we will be using MPLAB X, actually. And so they have some firmware and stuff, but they're really long-winded, and I try to stay away from microchip stuff as much as possible because they make it complicated. They used to be really good for the hobbyist and amateur people, but it's gotten bloated. They have this thing called Harmony to generate code for you, and it's just bloated and hard, and it's hard to set up, and I just stay away from it. I'm an anti-Harmony microchip programmer. And so let's go to the device overview. And so this is one thing about the data sheets for a lot of microchip stuff. They give, like, the main data sheet is just a basic reference, and then when you want to get in more specifics, then you want to go to this link right here, and then it'll take you to some other stuff, and we'll come back to that. So this is the basic overview of the microcontroller. There's the block diagram of what's inside. So it has all these ports. It depends on the package size. The 144 pin package will have everything. The 100 pin package that I use, I don't think it has all the ports. I don't think it has J and K. I think it has H. But it has most everything else. It may reduce the timer amount or something, but this is pretty much the basic diagram of it. So the next thing is the guidelines for getting started. So this is what you need: basic connection requirements. So all VDD and VSS pins have to have decoupling capacitors, although it will work, but this is what they're saying. And so all the AVDD and AVSS pins for the analog to digital converter, those need decoupling caps too. So you can just think of those as VDD and VSS basically in that respect. All right, so the active low MCLR, the memory clear pin, or the master clear, that's the reset. So our power on reset supervisor will keep that pin low until the power stabilizes and then release it, or you can use an RC network to do that. All right, and then the PGEC and PGED pins, that's part of the ICSP. That's how you program it. So you got to have those pins in order to program the microcontroller. But you can use those pins for other things as long as you don't add any capacitors, diodes, or pull up or pull down resistors on it, because those pins have to remain undisturbed for the programming. And that's with the master clear pin too. It can have the RC to hold it low for a short amount of time, but there can't be any diodes or any other components connected to it that will inhibit any kind of operation. And so that's why I have the reset jumper. We'll get into that later. So then you have, I use an external oscillator. It has internal oscillators, but they're not as good. They're not as stable as aftermarket oscillators. So on MainBrain, we use 2 external oscillators, one for the main oscillator and one for the real-time clock. All right. So here's a diagram of kind of how it's supposed to be. Recommended minimum connection. And if you see the L1, it has a footnote. It's an option for ADC noise rejection. I've experimented with that a little bit. I haven't gained anything from it, so I just used the straight direct connection for that. So it covers the master clear pin, like I was saying before. It comes down, and here is the hookup for the ICSP. And pin 6 is no connection, and I only use 5 pins. Six pins was old legacy thing. I'm not sure what it did. I think it was for debugging or something, but I can't remember. It's been so long. I've used 5 pins for a long time, so just figure on it being 5 pins. And so there's the basic master clear pin. How you can do that with an RC network. As you'll see later, I use a supervisor for that. And then you have the PGEC and the PGED. Those are serial lines for the programming from the PIC kit. The programmer. All right, so that's the basic thing that you need right there. You just need some power. You need to hook the ICSP up. You need bypass caps, and somehow you're going to reset the microcontroller. All right, and that's the absolute minimum. If you do that, you can plug in the programmer and you can write code. You can program it, no problem. And it works real good. I've never had a problem with it. All right. So here it tells you about the ICSP pins. All right. And then it says right here, pull-up resistors, series diodes, and capacitors on the PGEC and PGED pins are not recommended as they will interfere with the program or debugger communications to the device. All right. So, I mean, there's no reason to do that anyway. It depends on what you're using the pins for in actual runtime. But yeah, just follow that. You'll be okay. And it says here, ensure that the communication channel select are programmed into the device. And that's, we'll get into that, but it really isn't that big a deal. All right. And so JTAG, I don't do any JTAG, maybe in the future, but you can look into that yourself if you want to. So then We have external oscillator pins, and so we'll be doing that. And it says unused I/O pins should not be allowed to float. I haven't never had any trouble with that at all. But you can do that in software. They have pull-up resistors in software, and then, like it says, you can program those outputs. Okay, so that is some of the data sheet to get things up and going. So basically, for the microcontroller, you'd have to have it on the board somehow, but you could do that on like a QFP adapter board and solder parts onto the adapter board and have your little mini software development platform if you wanted, because so you only need the bypass caps on the between the supply and the ground pins, and I think there's like 5 sets of those, and the ADC supply and ground common. And then you need a reset, but actually if you have the PIC connected, it will reset the device. So you could actually do away with the reset because the reset pin is connected to the PIC or the PIC kit programmer. So you could get away with that, and then that's pretty much it. You just get the bypass caps, you get the thing powered up, 3.3 volts. You don't want to go over that. And just plug your programmer in, and then you should be ready to go. It's that simple. All right. So now let's take a look, go a little bit farther, go to the Microchip website and see what they have. So going back to the device overview, where they talk about further reference material, going further with it. So if you click on this link here, it takes you to the Microchip site. You have 3 kinds of 32-bit CPUs, and you have the ARM Cortex cores, which I may do one later with ARM. I've always wanted to do ARM, and I never have. But main brain uses the middle one, the MIPS 32 core. All right, so you can click, you learn more, and then it gives you some information about it. Microchip is pretty good. It has a lot of information. It has free tools. And if you go to forum.microchip.com, then you will find their Microchip community forum, and they cover everything that pertains to Microchip products. They have different topics. It's almost endless. You can ask questions, people will answer them, and it's invaluable when you're designing a microchip-based product or project. I've used it numerous times. As you get better, you can rely on it less, but just starting out, when you just can't figure something out, ask the Microchip forum. It's never taken longer than a couple days to get an answer, and usually it's pretty simple answer. Sometimes it's not, but you will get an answer, and it will help you continue on in your project, because sometimes it gets kind of hard. And I've relied on Microchip forum many times. I recommend signing up. It's a free to sign up and make an account, and it's very important. Okay, so that was the Microchip website and the Microchip forum. And even if you don't have a question, if you get signed up on the Microchip forum, you can just go through and read some of the questions people have and some of the answers and stuff. And there's a lot to learn there. So enough of that. The next thing we want to do, I want to show you how the reset circuit and the ICSP interface work together and interface to the microcontroller. So let's take a look at the circuit for that. So here's the reset circuit as well as the ICSP. I put those together because they're so interconnected that I think it's good to talk about both of them at the same time. So this is our ICSP connector right here, 5 pins. So you got VPP, which goes to the master clear pin of the CPU. And we have VDD and VSS for voltage supply. And so we have PGD and PGC, which is the actual serial programming, and they go to the pins on the microcontroller. Now I have a reset supervisor that is connected to the master clear, but we have a jumper shunt here so that it can be disconnected from the ICSP circuit if needed. Usually you don't have to disconnect it, but just in case that you have to connect it so that it complies with the specification that says you can't have any other components on the master clear pin. Okay, so if you wanted to do an RC circuit, they would just connect right here without the MCP, the master or the reset supervisor. All right. The reset supervisor guarantees that the master clear pin will stay low until the voltage reaches a certain point and stabilizes. Then it releases the master clear pin. So does the RC circuit, but not as precise and reliable as the reset supervisor. And then the reset supervisor just has a bypass cap next to it for noise, high frequency noise and immunity if needed. And then you have your supply voltage, 3.3 volts, and then your ground. So that's pretty much the whole circuit right there. And we'll take a look at the data sheet on the reset supervisor real quick. So it comes in different packages. You can get a through-hole package. It comes in different configurations, so you can get your pins a different place, which is kind of cool for your PCB layout. So we're using the SOT23-3 package, and we're using the MCP130. The only difference between the 120 and the 130 is a 5K pull-up resistor built in. So we don't have to add a resistor ourselves because the line has to be pulled up normally. So that's like the internal circuit, basically. You can order different levels of voltage, the trip level, they call it, trip point. So we're using the 300 number, which is typically 2.925 volts. So basically, if the power drops below 3 volts, then it gets a reset, and it doesn't allow the voltage, or it doesn't release on power up. It doesn't release the memory clear pin, master clear pin. I don't know why I keep saying memory clear. The master clear pin of the CPU. It releases it once it hits this threshold, and that means the voltage is up and stabilized so that you don't get some kind of spurious startup problem. All right, so that's basically it. There's not much you can really talk about. This shows you how it works. So as VDD is coming up, once it hits this point, then it waits, and then it releases the reset pin. And that works real well. Very reliable, more reliable than an RC circuit, but a little bit more expensive. All right, and this is basically how we have it. This is how it works, except we have a jumper in between to disconnect it if we want. So that, and then you can go through the data sheet, learn more about it if you want, but that's the basics. All right, so that's basically the reset circuit. And so once you get a reset circuit and you have an ICSP interface to plug the programmer into, then you're ready to go. So the next thing to do is, well, we'll have to take a look at, we got to get the IDE downloaded, we got to get the compiler downloaded, and we got to plug in our programmer. So there's various programmers you can use. So in the next video, we're going to go into all that because we've hit the end of this video. And so I will see you then.